So in this video, we're going to talk about how to simplify rational expressions. So what you're going to do to simplify rational expressions is you're going to factor the numerator and denominator. Remember to always look for a GCF first whenever you're factoring, and then what we're going to do is we're going to cancel any common factors that we have in the numerator and denominator. So let's look at this example. So this is like our best sort of example because notice everything is already factored. So what you're going to do is you're going to look for common factors in the numerator and denominator, and then you're going to cancel them. So you can see here we have an x minus 1 in the numerator and denominator, so we can cancel them. And this whole entire expression is going to simplify to x plus 4 over x plus 2. And so that is now our final answer. So now let's try this example. So here it's not already factored for us, so we're just going to go ahead and factor what we have. When I'm doing this problem, I like to number the numerator and denominator and color code it so I can keep track of what it is that I'm working on factoring. So number one, I'm going to work on factoring x squared minus 9x plus 14. So this is a situation where a is equal to 1, so I just need to find two factors of 14 that are going to add up to negative 9. Well, 14 is positive, so my factors will have the same sign. 9 is negative, so both those signs will be negative. So the best combination that works here is negative 2 and negative 7. So this is now going to factor to x minus 2, x minus 7. So now let's factor the denominator. So we have x squared plus 5x minus 14. So now we need two factors of negative 14. Well, since 14 is negative, we're going to have a positive and a negative factor. The factors need to add to 5, so we're going to make our bigger factor positive. And so if we think about the factors of 14, we have 1 and 14, 2 and 7. And so if you make the bigger factor positive, smaller factor negative, negative 2 and 7 are the best combination. So we have x minus 2 and then x plus 7. So now what I'm going to do is I'm going to take these factored expressions and then rewrite the original rational expression that I have. So I'm going to rewrite this now. And so in the numerator, I have x minus 2 times x minus 7. And in the denominator, I have x minus 2, x plus 7. So you want to be very careful when looking for common factors that the factors you're canceling have the exact same sign. So x minus 2 and x minus 2 will cancel, but x minus 7 and x plus 7 will not cancel, right? Because they have opposite signs. So our fully simplified expression is now going to be x minus 7 over x plus 7. So now you can go ahead and pause the video and try doing this example on your own. So here when you factor the numerator, you get x minus 3 times x plus 5. Denominator factors to x minus 3, x plus 7. So when we write this expression all in factored form, notice the x minus 3's will cancel, leaving us with x plus 5 over x plus 7. So now let's try this example. So now we need to factor, once again, same process as before. We number the numerator 1, denominator 2. Okay, but this factoring is going to be a little bit different because notice here we have two trinomials where a is not equal to 1. So we're going to have to use the a times c method, right? So we're going to take 3 times 10, which gives us an a times c of 30. So now we're going to find two factors of 30 that add up to 11. So that's going to be 5 and 6. So remember, now we need to use factoring by grouping, right? Because a is not equal to 1, so we have to expand out that middle term. So we have 3x squared plus 5x plus 6x plus 10. Okay, let's put the terms into two groups, 3x squared plus 5x, and then plus 6x plus 10. Remember, now we want to factor out the GCF of each group. So from the first group, we just have a GCF of x. So we're going to have 3x squared over x plus 5x over x. And when we simplify that, we have x times 3x plus 5. Okay, now let's factor the second group. So from 6x plus 10, we can factor out a common factor of 2. And so we have 6x over 2 plus 10 over 2. So that is now going to become 2 times 3x plus 5. Okay, remember when we finally write this in factored form, we pull out this common factor, right? This 3x plus 5. So that's going to be one of our factors. So we have 3x plus 5, and then we just write the terms that remain, right? The x and then the plus 2. So we have 3x plus 5 times x plus 2. Okay, so we're not done yet. We're only halfway done. We need to now factor the denominator. So the denominator is 3x squared plus 20x plus 25. Once again, a is not equal to 1, so we're going to go ahead and multiply a times c. So we have ac equals 75, okay? So we need two factors of 75 that are going to add up to 20. So the correct combination is 5 and 15. So I'm going to use that to expand out the middle term. So 3x squared plus 5x plus 15x plus 25. Okay, so we're going to put these terms into two groups, 3x squared plus 5x plus 15x plus 25. Okay, so we look at the GCF of each group. From the first group, I can factor out an x, so I have 3x squared over x plus 5x over x. And that's going to simplify to x times 3x plus 5. And now let's go to the second group. From these two terms, I can factor out a 5. So I have 15x over 5 plus 25 over 5. So that's going to simplify to 5 times 15x over 5 is going to be 3x, and then plus 25 over 5 is going to be 5. So we now have this fully factored form 3x plus 5 times x plus 5. So let's plug this all back into the original expression so we can simplify things. So in the numerator, we have 3x plus 5 times x plus 2. Okay, and then in the denominator, we now have 3x plus 5 times x plus 5. So if we look at this, we can see that that 3x plus 5 is a common factor that we can go ahead and cancel. So this is now going to simplify to x plus 2 over x plus 5. Okay, so that is now our simplified expression. So now you can go ahead and pause the video and try doing this example on your own. So here, when we factor, the numerator is going to factor into x plus 7 times 2x plus 5. The denominator is going to factor into x plus 3 times 2x plus 5. So when you write the original rational expression in fully factored form, the 2x plus 5 will cancel, leaving us with x plus 7 over x plus 3. If you need a quick review of any of the factoring that I did in this entire video, make sure you go back and watch the factoring videos that are linked in the course. So remember, you can simplify rational expressions by factoring the numerator and denominator, check for a GCF first, and then cancel any common factors.